Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hasrul Fitri bin Ahmad, and I would like to present about my final year project title. My final year project title is about motion control of rotational crane robot using Arduino. My final year project is under the supervision of Prof. IR Dr. Muhammad Azmi Ayub, and my co-supervisor is Dr. Muhammad Hanif Ramli. First of all, I would like to explain about my project background. Motion control of rotational crane robot using Arduino was a continuation of previous research on development of control system for inverted pendulum. The term of ganti robot represented by a full-rota pendulum that is an inverted pendulum concept that pivots around the end of the main arm that is driven by DC motor and the data recorded by a encoder. The main purpose of motion control of rotational crane robot is to move a load as fast as possible without causing any excessive sway at the final position. This research will design a new control method that will eliminate the sway angle of the ganti robot. The requirement of accurate and final load position requires the trajectory planning of a ganti robot that can eliminate the residual sway of the load. Thus, this research will address some of the issues in developing a new control method of the ganti robot using Arduino. Next, I will explain about my problem statement. There is a 4 problem statement that I find in this research. Number 1 is move a full-rota pendulum from one place to another without causing a residual vibration, as the full-rota pendulum system have a vibration when it moves to another place. Number 2 is the physical experimentation on full-rota pendulum will be difficult as it located at faculty and the university restricted the student to going there. Number 3 is so it possible to make the simulation on full-rota pendulum system, but the result would be slightly different with the previous study. Number 4 is thus this study will innovate the possible and effective way to eliminate the residual vibration. On this motion control research, there are 3 main objectives, which are to study and model the control of ganti robot motion. Number 2, to formulate and program control algorithm using Arduino microcontroller. And the number 3 is to evaluate the performance of the robot. There are 3 expected results that we get at the end of this research. Number 1 is the control of ganti robot motion will be studied and modeled. Number 2 is Arduino microcontroller will formulate and program control by algorithm. And the number 3 is the performance of the robot can be successfully evaluated. Okay, the scope of work of this research is this research was restricted to the control and vibration area that related with rotational inverted pendulum, which is full-rota pendulum. Number 2 is the experimentation is conducted to define the possible way to eliminate residual vibration or sway angle when the movement of the pendulum from one place to another. The test will be using the full-rota pendulum system. The experimentation should be done on the laboratory at the Faculty of Mechanical Engineering UiTM Shah Alam and will be assisted by supervisor and lab assistant. And the final is from the study, the accurate data and clear concept about the research will get when going the physical experiment on full-rota pendulum system. Okay, to assist my research on motion control of rotational crane robot using Arduino, I make some literature review to help me to complete this research. Number 1 is I make a literature review on motion control system, a range of field of automation purpose including precision engineering, microprocessing, biotechnology and nanotechnology. A motion control system is commonly used. Then go to the controller, a robust and unified control that could be placed into a secure enclosure and have anything attached to it was previously programmable logging controls, which is PLC. This research paper about motion control I get from the Fundamental of Motion Control article. Number 2 is position control system. The structure of the control system is simpler and has a rapid dynamic response, while parameter recognition is not needed. Exact position control can be done at the end of flexible arm. The research paper about position control system I get from the position control for linear motion servo system via nominal characteristic trajectory following controller and position control of a flexible ganti robot arm using smart actuators. And the number 3 is transfer function of DC motor and control system. The survey found that continuous transfer function model used in modeling engineering control system have the widest application. It describes the system input-output behavior. As you can see on the slide, there's a figure that represents the impulse response graph. And this article about transfer function of DC motor and control system I get from the transfer function modeling, a literature survey, and the role of transfer function in the study of stability analysis of feedback control system with delay. Then we go to the PID control. The PID control system example is PID temperature controller, which can control temperature mainly without extensive operator involvement, and digital PID controller that reads the sensor signal normally from a thermocouple of RTD or RTD and connect the measurement to engineering units such as degree and Fahrenheit. This PID control article I get from the PID controller optimized by genetic algorithm for direct drive servo motor and incremental encoder in electrical drive modeling and simulation. Next, for the important part is input shaping. Input shaping is a basic way of minimizing residual vibration as likely damped devices are placed. The shaped input function is derived from the defined output function. As you can see on the slide, there is a graph that represents the effect of system when using input shaping. The input shaping article and research paper I get from the input shaping for vibration-free positioning of flexible system. And finally is encoder. The incremental encoder was integrated into the simulation structure of an induction motor based drive control system in order to provide the position of the motor shaft. If one position has a high value, the next position will have a low value. This encoder research paper I get from a look into rotary encoder types, which is absolute and incremental. Next is methodology. For my final year project 1, I made a literature review and gathering data and planning for my methodology. For final year project 2, which is for the next semester, I made the methodology start from the coding, and then I will do the experiment of by using the full rotor pendulum, and from the data that I get from the full rotor pendulum, I made a calculation and analyze the result. After that, I made a documentation. Okay, for the preliminary outcome, you can see that they have a two graph, which is the expected result would not have a greater difference from the previous one. The graph show below represent the position or the vibration of the full rotor pendulum when it's moved from static to some points or angle. At the figure number 3 is show the pulse versus time of the full rotor pendulum, and the figure is the graph when the pendulum is moved. At the final slide is my project Gantt chart, which is I start with a project title selection with the completion on week 1 until week 2, and my literature review is start from week 3 until week 14, and I drafting of research proposal start from week 5 until week 8, and I construct a design at week 9. I make a modeling and analysis at week 10 and 12. My proposal writing is start from the week 10 until week 13, and submission of the proposal slide is at the week 14. As you can see on my project Gantt chart, I follow all the targeted time that I want to complete my proposal. That's all from me. Thank you.